With the Stats Medic, and in this video we're going to talk about the general addition rule, and we're going to do that using the activity Can You Taco Tongue and Evil Eyebrow. So we have two learning targets that we'd like to address in this lesson. The first one is to use a two-way table or to use a Venn diagram to model a random process and then be able to calculate probabilities involving two events. And then the second learning target is to get at what's called the general addition rule in order to calculate probabilities. So let's take a look at the activity. Can you taco tongue and evil eyebrow? So it says some people believe that the ability to taco tongue and evil eyebrow is something that you are born with. Is this true? Are the two abilities somehow related? Now let me start by trying to model for you what each of one of these would look like here. So the taco tongue is easy. Yes, that means that I can taco tongue. Now the evil eyebrow, you have to get one eyebrow higher than the other, which very clearly I cannot do. So I am a person who is a yes to the taco tongue, but a no to the evil eyebrow. So within this two-way table that we see in question number 1, I would be in this category over here of yes, taco tongue, no, evil eyebrow. Now, in order for you all to be able to do this activity, we have to have class data. And so I saved some class data from last year, and I'm going to share that with you, and I'll just have you use this class data here. So go ahead and record these numbers here. There were 15 students that were yes, taco tongue, and yes, evil eyebrow. There were 5 students like me who were yes, taco tongue, and no evil eyebrow. 3 students who couldn't taco tongue but could evil eyebrow. And then there were 7 students who could not do either. So that's all the information that you need in order to complete the activity. So go ahead and work through all the way through question number 4, and then come back here in order to check your answers. So you go ahead and pause the video now. Let's go ahead and check your answers in the activity. So for question 1, I gave you the values in the two-way table on the left there. So let's label this as a two-way table. But then you had to take those values and figure out where they belonged over here on the right in the Venn diagram. So when I am putting values into a Venn diagram, I always start with the overlap between the two circles here. So the left circle is yes, taco tongue. The right circle is yes, evil eyebrow. This center section would be yes for both. That looks like the football section is what I call it. And that is the overlap between the two, which is 15. Now the next thing that I go for is what I call the left Pac-Man, which would be the yes, taco tongue, but no evil eyebrow. And that is this value of 5. Then we go over to the right Pac-Man, which is no taco tongue, yes, evil eyebrow. And you'll see that over here in the two-way table. And then, of course, the last spot that we have remaining is just the outside value here, which is no taco tongue, no evil eyebrow there. So the 4 sections that you see in the Venn diagram are the left Pac-Man, the football, the right Pac-Man, and then what I call the outside. Now let's see if we can use the two-way table in the Venn diagram to answer some questions about probability. So for number 2, probability of yes, taco tongue. Well, there's a couple of different ways we can handle this. Yes, taco tongue, we can just look at the total of that row there. Or within the Venn diagram, yes, taco tongue is this whole circle. The 5 and the 15 are going to give you the value of 20. Now for the next one, yes, evil eyebrow. So if we're trying to find yes, evil eyebrow, we can look at the two-way table and look at the total for the yes, evil eyebrow is 18. Now you can also see that in the Venn diagram here. The yes, evil eyebrow circle has a 15 and a 3 in it, which are going to add up to 18. That'll give you the probability of 18 out of 30. Now the next one, no taco tongue, of course, is just the complement of this. So really you're doing 30 out of 30 minus 20 out of 30. That's the remaining 10, and that would give you your 10 out of 30. And same thing over here, you could do 30 out of 30 minus 18 out of 30, and that's going to give you the probability of no evil eyebrow as 12 out of 30. Now for the remaining 4 questions that you see here in number 2, it really just corresponds to the 4 values in the two-way table or the 4 values that you see in the Venn diagram. So the 15 out of 30 is the center football section in the Venn diagram. The 3 out of 30 is the right Pac-Man. The 5 out of 30 is the left Pac-Man. And then the 7 out of 30 is the outside value. Okay, let's move to question number 3. It says, suppose that we want to randomly choose a student from class, find the following probabilities. Well, we've actually already found these first 2, right? We know yes, evil eyebrow, and no evil eyebrow. We've already done that here at 18 out of 30 and 12 out of 30. So for the next question, the probability yes, evil eyebrow, or no evil eyebrow, well, that should be everybody, right? 30 out of 30, because you're either yes, evil eyebrow, or you're no evil eyebrow. And so mathematically, the way that we could calculate this is we could just take the probability of yes, evil eyebrow, and add to it the probability of no evil eyebrow to get the probability of yes, evil eyebrow, or no evil eyebrow. So if we were to try to generalize this to write a formula here, let's write this this way. The probability of 2 events, A or B. So A would be yes, evil eyebrow, B would be no evil eyebrow. And what we're seeing over here is that to find the probability of A or B, we just have to take the probability of A and add to it the probability of B. Pretty straightforward formula. So let's try the last question, number 4. The probability of yes, taco tongue, and yes, evil eyebrow, we've already calculated those. We know that's 20 out of 30 and 18 out of 30. And so the very last question says the probability of yes, taco tongue, or yes, evil eyebrow. Well, we have those 2 values right there. So let's just take our 20 out of 30 and add 18 out of 30. Now, very quickly, you're going to realize that this presents a problem here, because we're going to end up with 38 out of 30. And we know that you can't have a probability greater than 1. And so this formula that we were using for number 3 doesn't seem to be working here. And maybe we can figure out why. So let's go back to the two-way table and look at these 2 events. Okay, the first event is the probability of yes, taco tongue. So that is this row right here. And we know that there are 20 of those students total. The second event is yes, evil eyebrow, which is this column here. And we know that there are 18 total. But you see the overlap section there that is now highlighted is these 15 students, because these 15 students were counted as part of the 20, but they were also counted as part of the 18. So it appears that we have double counted those 15 students. So hopefully we can just subtract out the people that we've double counted, and that will allow us to arrive at our answer. Our final answer here should be 23 out of 30. Now let's see if we can generalize that into a formula here. Okay, once again, we are trying to find the probability of A or B. And we started out by just trying to do the probability of A plus the probability of B. And that didn't work here because we had double counted those 15 students. So we had to subtract out the overlap. So what we're subtracting out there is the probability of A and B. And so this formula that you see right here, this is what's known as the general addition formula. Now let's take a minute to pause right here and look back at question number 3 and try to think about why we didn't need to use that formula in number 3, but we did need to use the formula in number 4. And the reason is, in number 3, the 2 events that we have there, yes, evil eyebrow and no evil eyebrow, they can't occur at the same time. A student can't be in both of those events at the same time. And so we say that those 2 events are mutually exclusive. And when you have mutually exclusive events, you don't need that fancy general addition formula because there is no overlap. Essentially, that last thing we would subtract out would be 0. Now, question number 4, yes, taco tongue and yes, evil eyebrow, those 2 events can occur at the same time, right? You can have a student that would fit into both of those events, yes and yes. So here, the events are not mutually exclusive. And so if you have two events that are not mutually exclusive and you're trying to find the probability of A or B, you must use the general addition formula. So let's see if we can summarize what we learned here in the important ideas. For the important ideas, let's take a look back at the learning targets from the beginning of the lesson. The first learning target was about the relationship between the two-way table and the Venn diagram. So let's just go ahead and write in here learning target number 1. And this will be all about the two-way table and how it relates to the Venn diagram. So I'm going to start with just a generic drawing of a two-way table here. So let's draw one where there's 4 different possible outcomes. Let's draw a rectangle here, split it in 4. And let's just call this event A here. And so the one below that would be the complement of A. So I'm going to write that as A to the C. That is the complement of event A. And then this would be event B. And then, of course, the complement of B. And so there are 4 different possibilities there. So let's just label these as 1, 2, 3, and 4. And let's see if we could identify where those would show up in the Venn diagram. So let me go ahead and draw a Venn diagram. We have 2 events, event A and B, that are overlapping. So let's call that event A and this event B. And so number 1 would be the overlap of the 2. That's the center football section there. Number 2 is in circle A, but not in B. So that's going to be this one right here. 3 is in B, but not in A. And then 4 is outside of both of those. So you can see the close connection between the two-way table and the Venn diagram. And then once you have these created, you can use these to answer questions about probability. All right, the second learning target for us was about that general addition rule that we had to use for an OR probability. So let's go ahead and label this as learning target number 2. And this, of course, is the general addition rule. So let's start by just writing the formula out that we came up with. And that was the formula for the probability of A or B, which we decided we could get by adding the 2 probabilities, the probability of A plus the probability of B. But then the problem being that we double counted some of the students and we had to subtract out the overlap. So we want to subtract out the probability of A and B. Now, we had to use that formula because the 2 events were not mutually exclusive, right? They could occur at the same time. Now, let's look at the special case when the 2 events are, in fact, mutually exclusive. So we'll say if A and B are mutually exclusive, which means that they can't occur at the same time. Well, in that case, the probability of A and B, because they can't occur at the same time, would just be equal to 0. And we'll say since they cannot occur together. Now that's going to simplify the formula for us here. So that general addition rule that we have is now going to look like this. The probability of A or B is just simply the probability of A plus the probability of B. And we don't need to subtract out the overlap because there isn't any. That value is 0. So now that we have the important ideas, let's see if you can apply your learning in a new context here. So why don't you try to check your understanding, and then you can come back here to check your answers. So go ahead and pause the video now. Let's see how you did on the check your understanding problem. So the first thing you want to do anytime you're given values in a two-way table is to calculate your row totals and your column totals and your grand totals. So check your row totals here, check your column totals here, and then the grand total, there were 116 students that were surveyed total here. Now for part A, to explain in plain language what the probability of the complement of O means. Well, if we look back, O is defined as being over the roll. And so the complement of that would be not over the roll. So it's the probability of choosing a student who does not prefer toilet paper to be pulled over the roll. Now calculating the probability is easy if we've already gone ahead and calculated our totals in the two-way table. If we look at not over the roll, the total of that is 46. out of the 116 total is going to give us 0.397. Now, I do suggest on probability questions like this that you give the fraction that you use to get the probability as well as the final decimal answer here. Now, part B, they were trying to find the probability of O or R by just simply adding those two probabilities together. And we know from the activity that will not work if the two events are not mutually exclusive. In this case, they're not mutually exclusive because a student could be in both of those events at the same time. Now that of course means we need to use the general addition rule. So we're going to take the probability of O and we're going to add the probability of R, and then we're going to subtract the overlap here. And so we get an answer of 94 out of 116, convert that into a decimal of 0.810. Part C, we had to take the two-way table and turn it into a Venn diagram here. So you're just taking those four values and making sure that you place them in the correct location in the Venn diagram. And then hopefully we can use that Venn diagram to answer the last question, part D. So in this problem, we're looking for the probability of does not replace the roll and prefers the toilet paper pulled over the roll. And so we can see that that is in the Venn diagram right here in the left Pac-Man, 12 total out of the 116, which is going to give a final answer of 0.103. So this concludes the video on the general addition rule. Thanks for watching.